All right, page 294 has the error of each of them. So E sub t stands for the error created with the trapezoidal rule is always going to be less than or equal to b minus a over 12 times h squared times the maximum of the second derivative of the function. So that's not sub or anything, that is literally h squared. And this right here is the max of the second derivative of f. So it says that the error using trapezoidal rule will always be less than or equal to this. Simpson's will always be less than or equal to b minus a over 180 times h to the fourth times the maximum of the fourth derivative. Alright, so that is h to the doesn't really make sense to rewrite. H to the fourth is h to the fourth. And this right here is the maximum of fourth derivative. Alright, so if we have this for our equation and we're going from 0 to 4, let's find the error error using Simpson's. Okay, so here's our error for Simpson's. It's going to be less than or equal to b minus a, so it's 4 minus 0, so it's 4 over 180 times h. What's h in this problem? It's 1, right, because it's h is b minus a over n, so it's 4 minus 0 over 4, so it's going to be 1, which is helpful. We can take 1 to the fourth. And now we have to find the maximum of the fourth derivative of our function. The maximum of our fourth derivative. All right, so f prime is 5x to the fourth minus 12x squared plus 20x. At least it's a polynomial. It's doable. F double prime is 20x cubed minus 24x plus 20. F triple prime is 60x squared minus 24. The fourth derivative is 120x minus 24. We want to find the maximum of the fourth derivative on the interval from 0 to 4. So this is just a line. It's an increasing line because it has a positive slope. So where on our interval would it create the maximum? Well, it's going to be 0, which is negative 24. So that's possible because we're doing absolute value. So, but if I plug in 4, you get 480 minus 24. What's that, 456? So 456 looks like it is the maximum. It's the biggest the derivative, fourth derivative could be on the interval. What did I say it was? 456? So what at 456 times 4? And divided by 180. Math, enter, enter, and I get 152 over 15. So when we use Simpson's on the interval, it will be smaller than or equal to 152.52 over 15 as far as the area estimation goes. What if this was a quadratic? What would the error be then? We already just talked about it. If that was a quadratic in x squared, what would the error end up being? it would be 0. So there's a couple ways to say that it'd be 0. Well, knowing what Simpson's is, it's a parabola on the top of a shape. So that's one way we could justify it. Mathematically, does it check out using the Simpson's error? If that was an x squared, why would it be 0?
Would the max of the function be 0?
Right. You'd find the max of the function would be. So you do one derivative, another derivative, you do 4 derivatives, you're at 0 already. And we're plugging that in right here, so its error is going to be 0 because your 4th derivative's maximum is, of course, going to be 0.
I have a quick question.
Yep.
Why do you keep the minus 24 for the 4th derivative?
Oh, did I forget to get rid of it? Oh, thank you. Yeah, sorry, I shouldn't have. So, just a mistake on my half. So that's 0, so it's 120x. So if I plug in 4, I get 480. So this should be 480. And then over time, so whatever that turns out to be. 480 times 4.
I wasn't sure if you meant to do that or not.
I didn't mean to, no.